Hello everyone, welcome back to the class of biotechnology. My name is Dr. Farah Maarfi. In the last video, we have discussed the theoretical principle behind sedimentation, centrifugation. We have also solved several numericals related to the angular velocity and the sedimentation. Today we will discuss the operation of the centrifuge, means how you can operate any centrifuge machine, what is the basic procedure behind it, what are the major steps that we should consider. But before we move forward, be sure to click the subscription button and turn on the notification bell so that you won't miss any future video. Let's move forward to understand the basic operation of the centrifuge. As you all know that the centrifuge is an instrument that uses the centrifugal field to separate out the biological particle out of any suspension on the basis of the density. Actually, it is a super powered version of a normal blender which we are using in our kitchen. It requires high speed rotor to separate out the biological particle under the influence of centrifugal field. Like any other powerful tool, it requires proper handling to ensure safety and effectiveness. Sample preparation, balancing, loading and setting of time and speed, safety measures, sample handling are the key elements that actually should be focused upon during the operation of the centrifuge. But first of all, before we begin to operate any centrifuge, we should read the manufacturer's manual for our specific centrifuge model. So to avoid any mishap, suppose this is a sample and we want to isolate the DNA from its nucleus. So to obtain the DNA, the sample must be homogenized properly. So the first step is preparation of the sample. The sample must be homogenized properly, and in the second step, we should place this homogenized sample equally into the centrifuge tube. That means when you place the sample into the centrifuge tube, the tube must contain the equal amount of the sample into it. After that, when we proceed to the third step, the major concern is to avoid the wobbles. The centrifuge tube containing the same amount of the sample when placed into the centrifuge should be balanced. Like here, one tube is this side, one tube is this side. This is the super important step. So to avoid any breakage of the tube as well as to avoid the functioning of the centrifuge. In the fourth step, after you place the centrifuge tube into a centrifuge in a balanced way, you should close this lid firmly and proceed to set the appropriate time, temperature and RPM. These are the digital switches to set the temperature, time and RPM accordingly. These digital parameters should be set according to the experimental sample. Once you have set everything up, then you should start the centrifuge. It will spin very fast and separates the sample based on its density. The denser component will move outward while the lesser denser ones will stay closer to the center. After the set time is up, the centrifuge will gradually slows down to a stop. Be patient here, don't open the lid in hurry. Finally, in the fifth step, that is the final step, you have to unload the sample. Here ensure that the centrifuge is stopped completely. This is very important step to avoid any spills or accident. Once everything is still, you carefully remove your tubes from the rotor. Your sample should be settled at the bottom of the tube like this shown here. Once the samples are settled at the bottom of the tube, you can throw out the suspension. The upper liquid is called the suspension or the soup, and this is called the pellet. So this was whole about the operation, the procedure of the centrifuge. But few important key things I also want you to keep in mind while designing any centrifugation protocol. That is, the more dense a biological structure is, the faster it sediments in a centrifugal field. That means if the biological structure is having a greater density, then the sedimentation rate is also very much greater. In the second point, it is said that more massive biological particle is, the faster it moves into a centrifugal field. Again, if the particle is having a greater mass, then it will again sediments at a much faster speed or much faster rate in any centrifugal field. Again here the sedimentation rate will be more. In the third point, it is said that the denser the biological buffer system is, the slower the particle will move in a centrifugal field. Now, here it is talking about the buffer system, the system or the suspension in which the particle is suspended. So, if the density of the system or density of the buffer is denser than the density of the particle, then the particle will sediments at a much slower rate. That means the density of the medium, or you can say the density of the buffer, is more than the density of the particle, then in this situation the sedimentation rate is very much low. In the fourth step, the greater the frictional coefficient is, the slower the particle will move. Means again, if the system is having a greater density, then it will exert the some frictional coefficient onto the particle against the direction of the centrifugal force. In this condition also, the particle will sediments at a much slower rate. If the frictional means, if the frictional coefficient is greater, then against the sedimentation rate is slow. In this point, the greater the centrifugal force is, the faster the particle sediments. Means if the centrifugal force is greater, of course, the particle will sediments at a much greater speed. Finally, the sedimentation rate of a given particle will be zero when the density of the particle and the surrounding medium are equal. Means the density of the particle gets equal to the density of the medium. That means in this condition, the applying force on the particle, that is the centrifugal force F1, and a frictional force F2 will get equal to each other, and this will not allow the particle to move into any direction, and at this condition the particle comes to rest, and here the sedimentation of a given particle will be zero. So this was the basic behind any working procedure of centrifugation protocol. Thank you so much for today. In the next session we will discuss about the types of the rotor. Till then, thank you so much.